Hello again. As a complement of the last presentation, I would like to show you the utilization of those functionalities to implement 3D printing with a robot manipulator. You remember the workpiece that we used in the previous demonstration? The workpiece is this one, was developed to be a test case with 3D printing. So we used it in the previous presentation, and now I'm showing it to you just to remember the configuration of the workpiece. It was developed using a CAD package, and then we loaded into a slicer software, so a software designed to slice the 3D object. Here it is. We slice it with layers of 3 millimeters, so a normal collection of parameters adapted to our printing technology. So you see this is the workpiece sliced in this software. The layers can be seen here. All the layers until the top of the workpiece, from top to bottom of the workpiece. So with this Slicer 3R software, which is free and available for anyone, I generated a G-code, and with a small application that I will include in Robot Studio, I just this application just reads the G-code and extracts the positions, orientations, generates the orientations, etc., divides everything in layers and sublayers, and extracts or generates the robot code to be used with a robot controller. As you know, I'm using ABB robots, so the code generated by this application is of course adapted to be used with ABB robots. Here it is as modules divided in layers, so moves of the robots to the generated X, Y, and Z positions, and then the only thing we need to do is to find the configurations necessary to do these motions. So I imported this to Robot Studio, and we have here the layers, all the layers available. For this workpiece, we have a total of 46 layers with several sublayers. Everything was inserted into a path. I can see we can see the layers represented here. Here it is, all the layers that were imported. So this represents the motions that the robot needs to do. The robot needs to do to print this part. If you make a zoom, you see all the motion, all the trajectories there, and the necessary coordination to print this workpiece. So let me show you how it is printed. If we hire the layers and put the robot here available, if I simulate, this is a 5 minutes job to import from the generated code that was generated by the G-code from the G-code of Slicer. It's a 5-minute job to have this path assembled, and then we can I can show you it working and printing, showing the trajectories necessary to print. After a few minutes, you can see the trajectories that the robot is performing. And imagine rest is printing the trajectories as predefined by the slicer software. And okay, it's a question of waiting for the final printout. Okay, just to show you that after a few minutes, the robot already printed a few layers. You can see the number of layers here. It's working in the fourth layer, and the piece is getting printed. You see the holes here, and is building the walls, interior walls and external ones. The robot is working a little bit slow because I'm recording the video at the same time the simulation is being performed. With this program, with this application, we will also add the controlling program that was presented in the first demonstration, meaning a controlling application that calls the printing, that has voice activated features, etc. Again, after a few minutes of printing, you see the pieces already, work pieces are already very well advanced. You see the walls already, internal walls even, and over there, you can see them. This is it printed in red. Everything is in red, but you see the walls here, internal walls, the holes, and the external contour. The robot is still printing. It's moving slowly because I'm recording at the same time, but recording the video. So that's why the motion stops, because this is a simulation. Simulation inside Robot Studio. So you see it's equal to the real functioning of the robot. And it's already printed all these layers, so it's already in the final stages of printing. You remember we generated these paths using an external software called Slicer. Slicer just sliced the workpiece and then generated the G code for the printer to print this workpiece. I extracted with the program we have done, extracted the XYZ positions and generated orientations for this robot, an ABB ERB 140. And generated automatically also the rapid code to execute these paths, and the result is these represented paths. But as you see, this is a little bit complex to see, so we will hide this and show how the piece grows, let's say it like that, representing layer by layer, layer and sublayer by layer. So this is layer 1 and sublayer 1, which means that I'm starting to print the whole of the workpiece has 2 holes. So you see I'm selecting layer 1 and sublayer 1, and I can start representing everything. So you see the workpiece is growing. This is layer 1, and with all the trajectories and directions of that the robot needs to do to So this is the complete layer 1 with all the sublayers. I get for layer 1 40 sublayers. So you see you can manipulate it and see the trajectories to print layer 1. If you want to continue, let's select layer 2 and start printing layer 2. So I already went to layer 3. So this is layer 2. You can see that we have 2 layers already. 2 layers over here. So, and these are the result of the printing. And I can do everything. I can do show all the layers and have an idea how the workpiece will grow. So if I start growing it, you see the workpiece growing, and as all layers are being printed. Okay, so this is a way to show how the layers are printed. Okay, hope you enjoyed it. Thank you.